this question says find the fourth root of this minus 6i and then minus 16. Now, this question is simple, but then knowing how, like the tactics on how to tackle it is what matters. Now, I would just have to make it simple. Yeah. Um, you know very well that from the Moivre's theorem, our WK equals to r raised to power 1 over n, then brackets cos brackets pi m theta plus 2k pi over n plus I sine theta plus 2k pi over n, then this. So the issue of this particular question that to do with that root of complex number is always on the angle, because you have to do it over and over. Like now we are looking for fourth roots. Our care would range from 0, 1, 2 to 3 because it's fourth root. And we'll be doing this in like over and over up to the third one. And so I'll find all the angles like in this first one now, but then I'll now write the answers like this now. So the first thing we need to do, we'll find the angle. We also need to find arrow as well, but most importantly, the angle is always stressful. Is equals to square root of s squared plus x is the real part of this equation, minus 6i. And the real part there, there's no real part there, it's 0. So square root of 0, that's square. Then y is the imaginary part, that's minus 6. So minus 6 attached to that I. We have minus 6 all squared. How do I know? Look at this thing. Normally, our z is given generally as s plus iy. And this is also z. Z is given there as just minus 6i. So that means the imaginary part now is given, while the real part is not given, and it's just like saying plus 0. And it doesn't change anything. So s is 0 and y is minus 6. So when you solve this, this equals to square root of 0 squared is 0 and minus 6 squared. When the square minus, they have plus. 6 squared is 36. So this is 36. And this will end up giving you square root of 36. And that's equals to what? 6. In exam, whenever it's something like this, our array is always just that number that you have there. Positive of that number. Whether it is the imaginary part or the real part, like in this one now, the arrow here is 16. Arrow here is 6. Whether it was 6i, arrow is 6. So you don't need to stress yourself solving that. So we'll now find the angles. When k equals to 0, for the angle, if I don't now find when k equals to 0, 1, 2, 3. So theta equals to tan inverse of y over x. And as I already mentioned, y is the imaginary part. Tan inverse of minus 6 over 0. Now, this thing cannot be gotten from calculator. It's undefined. And even you cannot say because it's undefined, then it's 90 degrees. No. There's minus in that angle, in that number. So look at this. We'll draw what we call the Argand diagram. The Argand diagram is like this. Remember that this is y over x. So the y part now is on the negative part. And then our x part now is on the what? Is neither on the negative or whatever. We don't know. It's not in anywhere because it's just 0. So we don't know where it is. So what we'll do, there's a trick to this. Here is pi over 2. The angle here is pi over 2. This is minus pi over 2. And this is pi. And this is minus pi. So when I'm here, the angle is negative of angle 90. When, assuming this thing was plus now, it will be normal angle 90 degrees. It's 90 because 180 is, and pi is 180. So 180 divided by 2 is 90 degrees. Assuming you have the number on x-axis alone, that's, let's say just like this one now, we have, let's say it was 16 now, so it will be on just the x-axis alone, so the angle will be pi. If it was just on the negative axis alone, then the angle will be what? Minus pi, that's minus 180. So that's everything. So now moving forward, that means our angle here is just minus pi over 2, or 90 degrees, or minus 90 degrees, anyone. So I will be solving for the angle now. This angle inside here. When k equals to 0, 1, 2, 3. So at k equals to 0, our angle, this thing now, theta plus 2k pi all over n, and this equals to, theta is given as what? Minus pi over 2 plus 2 bracket, k is given as, the first one is 0. So 0 times pi all over n is 4 roots, n is 4. So over 4 equals to minus pi all over 4. This is 0, so it will go. So this equals to, same thing as saying 4 times 2, so you have 8. Minus pi over 8. So we are putting the first angle. So when k equals to 1, we'll have theta is still minus pi. Minus pi as at k equals to 1. We have our theta as minus pi over 2 plus 2 times k is now 1 times pi all over 4. And this equals to minus pi over 2 plus 2 pi all over 4. So this equals to minus pi, that's LCM of these two is 2. That's this 1 here. 2 divide 2 is 1. These 2 now divide this 2 is 1. 1 times pi, minus pi, plus 1 divide 2 is 2 times 2 is 2 pi all over 4 equals to minus pi plus 2 pi is what? All over 4. And this equals to pi over 8. So at k equals to 2. So we have minus pi already over 8. And then we have pi over 8. So at k equals to 2, our theta plus 2k pi over n is equals to minus pi over 2 plus 2 bracket 2 times pi. That's at k equals to 2. So all over 4 equals to minus pi over 2 plus 4 pi all over 4. And then this equals to, LCM is 2 all over 2 divided 2 is 1. 1 times minus pi is minus pi. This is 1. 1 divided 2 is 2. 2 times 4 is what? Plus 8 pi all over 4. This equals to 8, that's 8 pi plus minus pi is actually just 7 pi all over 2 then over 4 equals to 7 pi over 8. So we have 7 pi over 8. For this one, I think we made a mistake here. This would have been, when you say LCM of 2 and 1, you have 2. And when 2 divides 2, 1 times minus pi is minus pi, that's correct. 1 divided 2 is 2. 2 times 2 pi, 4 pi. And this will mean, instead of this, you have 3 pi. So we have 3 pi here. So this is actually 3 pi. So we do at k equals to 3 now. At k equals to 3. Our theta plus 2k pi all over n is equals to minus pi over 2 plus 2 bracket, k is what? 3. Then times pi all over 4 equals to minus pi over 2 plus 6 pi over 1 all over 4. And this is equals to, LCM is 2. As this 2 now, LCM is 2. 2 divided 2 is 1. 1 times is minus pi. Minus pi. 1 divided 2 is 2. 2 times 6 pi plus 12 pi all over 4. This is equals to 12 minus 11 minus, sorry, 12 pi minus pi is 11 pi over 2 all over 4. This is equals to 11 pi over 8. 4 times 2 is 8, so you have this. So you have 11 pi over 8. So our formula says that we have Wk as r raised to power n 1 over n brackets cos bracket theta plus 2k pi all over n. Then brackets plus I sine brackets theta plus 2k pi all over n. So we have the bigger brackets. So, and this is equals to, for the first one, W naught, our answer is, R is what was gotten as 6 when we solved it. R is 6. So we have 6, 1 over n is what? 4. Brackets, cos, the first one is minus pi over 8. Then plus I sine minus pi over 8. So find this equals to 4th root of 6. Then we have cos of this is same thing as cos of the positive one. So this is just cos pi over 8 plus, not plus, for the sign it's negative. We have minus I sine pi over 8. So the minus will come to the back. So for W1 is equals to, the same thing will happen here, 4th root of 6 cos 3 pi over 8 plus I sine 3 pi over 8. Then W2 is equals to 4th root of 6. Then this, that's cos 7 pi over 8 plus I sine 7 pi over 8. So this is the one. So I will leave you the last one. That's the last one of 11 pi over 8 to do as an exercise. Post it on the comment section. Thank you. So we have 3 answers, W0, W1, and W3. W0, W1, W2, and W3 are the 3 answers, the 4 answers we have, because it is a 4th root. So that's how to solve it.